we are at problem number 17. So let's see what we've got here. A neighborhood consists of a 2-hectare park and a 35-hectare residential area. So one of the things I like to do is draw a picture right away. And so here's a neighborhood, 2-hectare park. So not a very big park. I'm going to make my park go the long ways here. So this is like park, and that's 2 hectares, measure of area, and a 35, so this area is 35 hectares. I forget the unit or the abbreviation for hectare, so I'm using hectare. The total number of trees in the neighborhood, okay, so the whole thing is the neighborhood. This inside here is residential. So trees in the whole thing is 3,934 trees. The equation 2x plus 3y equals n represents this situation. Which of the following is the best interpretation of x in this context? So they've given us 2x and they're saying, hey, what's x mean? Plus 35y. What's y mean? And your total is 3,934. When you do this, multiply whatever x is times 2 and multiply whatever y is times 35, you get this number, which is total number of trees. Okay, so what this tells us, since the units of this are trees, the units of this term must be trees. And that's the units of this term right here. It's got to be trees also, so that you're getting trees plus trees equals trees. It's the way units work. They have to add to give you the same type of thing you're counting. So I'm counting trees, I better end up with trees. Or if I end up with trees, I better be counting trees. And that's going to help us figure out what this x means here. So it's taking 2 times whatever x is, and you can see 2 is this area. So you're taking area times x, and 35 is this area, so area times y. So if I just wanted to kind of figure it out with units, I'd say this is 2 hectares. I got to get units of trees. So whatever x is measured in, its units have to be like trees on top, and it's going to have to cancel the hectares in this multiplier here, so it's like hectares on the bottom. And so now, when I plug in x, which is going to be in trees per hectare, like if it's 5 trees for every hectare, then 2 times 5, I'd get 10 trees, because I have 2 hectares in the park region, this section right here. And so this is telling me, hey, trees per hectare. And that's what the y is in as well, but y is just some different number. But it's in trees per hectare that are inside. My mouse is kind of goofing up right now. But same thing with the trees per hectare for y. It's just some different number, but take it times 35, it tells you how many trees are in this region right here. So let's see here. What does x stand for? The number of trees per hectare in the park. Yep, that's what it is. Let's see what the other ones are and why they don't work. The average number of trees per hectare in the residential area. No, that would be for this one here, the y value. The total number of trees in the park. No, that's not what x is. And that's what they want us to figure out. The total number of trees in the residential area. No, doesn't mean any of those. It's just A. All right, next one, number 18. 18, we got company A, company B. Okay, the graph shows the relationship between the number of shares of stock from A, which is on your x-axis, and the number of shares of stock from company B, which is on the y-axis, that Simone can purchase. Which equation could represent this relationship? At y equals 8x plus 12, 8x plus 12y equals 480, yada, yada. All right, so let's see if we can figure this thing out. The first thing I would note is like way up here, I've got this point, and that point is a y-intercept. Okay, that's the point when x is 0, y is 40. So whatever equation it is down here, it has to go through that point. So you can see if x is 0, this first equation doesn't give me 40. If x is 0, this second equation might give me 40. I'd have to do a little division. If x is 0, y is 8, so it's not that one. So you can just rule out some of these right away. Let's see if this last one is. If x is 0, y is, you'd have to do some math there. And we'll just do that math now. It looks like we can just figure it out right away. We'll go, all right, if x is 0, so I'll put a 0 in for this x here. So it's 8 times 0 plus 12y equals 480. And this right away becomes 0. So I just really have to divide by 12. So y is 40. Hey, that's a good sign. So it could be this equation. It's probably B at this point. Sorry, B right down there. Um, but I'm not quite positive yet. So I got a couple choices. I could test it in this one. So let's find out if it's the last one. 12 times x, and I'm testing x is 0, plus 8y equals 480. That again is 0. So does y equal 40 here? Oops, should be dividing by 8. No, it doesn't, because 8 goes into 48 6 times, so that's 60. So no, this is the only one that goes through that point. That's probably the quickest way to solve that problem. Let's see here. Number 19, here we go. Circle has a radius of 3n. So we have radius equals 3n for a circle. So if I was drawing a circle, we usually put them right at the center of the xy axis. And there's a circle. And then this would be its radius. In this case, 3 ends. And circle B has a radius of 129 ends. Okay, so that's a much bigger circle. But now center all the way out to the edge, his radius is 129 ends, where n is a positive constant. So n is like 0.5 or 2 or 3 or 200. We don't know what n is. We just know it's positive and it's just always the same number. The area of circle B is how many times the area of circle A. Wow. So let's think about how area is calculated for a circle. So area is calculated with pi times r times pi r squared. Sorry. Okay, so the area of the blue circle, let's figure out what he'd look like. He'd be like pi times his radius is 3n squared. And the second circle, area equals pi times his radius is 129n squared. And they want to know how many times bigger is this one. So what we want to do is take the small one and we'll divide it into the big one and figure out how many times it goes in there. And they'll be like, hey, it's 50 times bigger. Okay, so we're just going to take these two. So let's take the red one. We'll put it in the numerator of a fraction. Pi times 129n quantity squared over the blue one. That's how you do division here. Sometimes we just write them as fractions. And let's just simplify this. Let's find out what this ratio of A, oops, I want the red one on top, of A red to A blue is. So I start to simplify this fraction. I can see the pi's disappear because pi over pi is 1. So this is 129 squared n squared. I have to square both. And the denominator is 9 squared n squared. So the n's are going to drop away. They don't matter. We just got to figure out what this ratio is here. Okay, so I'm going to get out my calculator. Now I'm going to simply type in what the heck is 129 squared. 129 squared, arrow over, divided by 9 squared is equal to, and oops, I need to be showing it on here. My apologies. Here we go. So I'm going to find out what 129 squared, arrow to the right, divided by 9 squared is equal to, and it says, it is 205.4 times bigger. And so I clearly have answered it wrong. Oh, sorry. I kind of made a little boo-boo right here. I can see it right now. So 129 squared is 129 squared. I haven't squared it. But here, 3 squared is 9. I've already squared my 9. So I can erase that little 2. I didn't square my 9, rather. I squared my 3. When I squared my 3, I got 9. There we go. And so now I'm just going to get rid of this little 2 up here in my little. There we go. 129 divided by 9, and I get 1,849. 1,849 times bigger. So there we go. That guy right there. Um, so it looks like it's just the ratio. In fact, I think this is one of our geometry theorems. You just have to find the ratio of their radii squared. So you have to go radii 2 squared over radius 1 squared. And that gives you the ratio of their areas. And you can see it right there in how the math worked out, that your r squared and your other r squared. All right, and that's it for those 3 on that page.